So if you haven't had a chance, go ahead and do this side of the note sheet where you're using the human memory model, and then come back and watch the rest of the video. All right, so on the model, the students had 50 new vocabulary words in a language they didn't know, and then the number of words that they still remembered after T days is given by that function. So I did a little graph of the function. And so what's happening with the human memory model is that the students are quickly forgetting the words, but even after a really long time, they didn't forget all the words. Okay, so after 10 days, there were 10 words the students remembered. After a year, a little more than 6. So you can use that information and then the graph to kind of see that the number of words that they remember levels off at 6. And if you remember from pre-calculus, that is a horizontal asymptote. And we can actually find the horizontal asymptote by looking at the function. And we'll review this on the back, but what you do is compare the degree of the numerator and the degree of the denominator, and they both have a degree of 1. So when they're equal, what you do is the leading coefficient of the numerator divided by the leading coefficient of the denominator. So 0.6 divided by 0.1 is going to give you 6, which is the horizontal asymptote. All right, and then 4, as we get closer and closer to 0, then this graph is going up, 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 because there is a vertical asymptote at x equals 0, but it's not valid for this situation because the students only started with 50 words. Okay, so that's kind of an introduction to connecting limits with horizontal asymptotes. So when you're finding the limit as x approaches infinity or x approaches negative infinity, which we're kind of doing with 3b, we're looking at what happens in the long term to the right. You're asking about end behavior or horizontal asymptotes. All right, and we're going to use the same rules we did last year to figure this out, but we have to remember them. But it's going to be a little different because the question is not going to be what is the horizontal asymptote. The question is going to be what is the limit as x approaches infinity, or what is the limit when x approaches negative infinity. So you have to connect those two in your brain. So try to remember the degree of the numerator is greater than the degree of the denominator. So we're comparing degrees on rational functions. So back in pre-calculus, what we would say is that there is no horizontal asymptote. Oops. All right, because we'll keep the function would keep increasing or keep decreasing. So in this case, when there is no horizontal asymptote, what we're going to say is the limit does not exist. And the reason is because y is either going to approach infinity or negative infinity. All right, so these two, when the degree of the numerator is less than the degree of the denominator and when they're equal, they both will have a horizontal asymptote. So that also means the limit will exist. All right, so try to remember when the degree of the numerator is less than the degree of the denominator, y equals 0 is the horizontal asymptote. So the limit as x approaches infinity of f of x is going to be 0. And then when they're equal, it's like what we did on this last problem, where you take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. All right, so that's just going to take some reviewing and studying to remember the rules, but you guys can do it. All right, so for our first check for understanding, we have a graph of f of x. We're going to just answer some questions about it. So first, we're going to list all of the vertical asymptotes. So we can tell by looking at the graph, there's a vertical asymptote at x equals -4 and at x equals 1. All right, and then for the horizontal, there is a horizontal asymptote when y equals 1. All right, so we want to find the limit as x approaches 1 from the left side. So we're approaching 1 from the left. That graph is going to go up, up, up forever. So that's going to be infinity. Now, that limit doesn't exist because infinity isn't a limit. It continues forever. But we can tell how it doesn't exist if we're doing a one-sided limit. All right, and then for the limit as x approaches -4. Now, this is not a one-sided limit, so if we're going towards -4 from the left, we're going down forever. From the right, we're going up forever, so this limit definitely does not exist. Okay, the limit as x approaches -infinity of f of x, so this means that we're going as far as we can to the left. That graph is flattening off where y is 1. So the horizontal asymptote is 1. That limit as x approaches -infinity is also 1. So try to remember when you're approaching infinity or -infinity, you're looking for the end behavior, which is going to be the horizontal asymptotes. All right. So for the next one, we're going to find the limit as x approaches -4 from the left. So that's going to be this one right here, which I've already drawn. So that the graph is going towards -infinity. All right, and then the limit as x approaches infinity of f of x, we're looking at our horizontal asymptote that is on the right side, which is going to be 1. Okay, so let's do a few where we don't have the graphs. All right, so for number 4, the question is just to find the limit, and you need to recognize that that is x approaching infinity. So x approaching infinity means we are looking for the horizontal asymptotes. So we're looking at the degrees. Those degrees are the same, or they're equal. So when they're equal, that's where you do the leading coefficient of the numerator, which is 5, over the leading coefficient of the denominator, which is 1. So the limit as x approaches infinity of that function is 5. All right. When we go to B, we notice it's the limit as x approaches -infinity, so that is asking for the horizontal asymptotes. We look at the degrees. The numerator is greater than the denominator, and when that happens, there is no horizontal asymptote, so the limit does not exist. Okay. So for number 5, we want the concentration of anesthesia, or we know that the concentration of anesthesia in a patient's blood stream can be determined by that function, where C is the concentration as a percent and T is time in hours. we want to find the limit as x approaches infinity of c of t. So that's telling us to find the horizontal asymptote. So to find the horizontal asymptote, we look at the degrees. This is a 1. So that means that the numerator's degree is less than the denominator's degree. And when that happens, the horizontal asymptote is 0. So that means the limit as x approaches infinity of c of t is 0. All right, and then B, interpret the meaning of the value found in 4, it should be 5a, sorry, in the context of the problem. So we got that the limit as x approaches infinity of c of t is 0. So that's after a really, really long time. So after many, many hours. The anesthesia. It's a weird word to spell, and I left out a T. Wears off. And the concentration goes to 0. All right. I'm not really sure why I have another 2 pages that are exactly the same there, but it's fine. So your assignment is going to be that worksheet.